and the result you see right here, it looks pretty neat. The LEDs are suspended on copper thread. It's very thin insulated copper wire. It's solderable copper wire. It's 3 LEDs per bottle, and that's really all of the magic. The bottle here on the left is powered directly through a power supply at this point in time. The hookups are right here. I don't know if you can see the copper thread. I think you can see this one right here because of the reflectivity. But this one here is powered from a battery pack and a constant current regulator. Let me switch the light on, and let's have a quick and closer look at how exactly I built these. This is not a big project, but I had many people ask me if I could build them one, or if they can have one, or how to do this. And so I thought I'll shoot a quick video on it, and if you're interested in building one of those on your own, well, watch this video. Let's open up this bottle over here. So I just unscrew the cap, and you can see the copper thread right here. And that's it. That's the magic inside. It's just 3 LEDs, a little bit of insulated copper wire. Now, if you do this, you should probably put a little drop of silicone or some other insulating type glue on these contacts. And in this case, they're wide open for the water, so you probably don't want any corrosion to happen there. It's not dangerous in any way. It's just not enough voltage, but you don't want your lamp to break after a short amount of time, just due to corrosion. And while we're talking about corrosion, you probably don't want to use tap water, but some sort of distilled water or something like that with a lower conductivity, just for the same reason, to prevent corrosion and make sure that your lamp lasts a whole lot longer. So this one is directly hooked up to a power supply, so not very interesting. Let's move that one over. This one right here, it's the same way. It's 3 LEDs suspended on very thin copper thread. And the electronics behind it is super simple also. There's this little battery pack with an on-off switch. It contains 4 AA batteries. And then there's a constant current regulator right here. It is a ST NSI 45090, I believe, and is set somewhere around 100 milliamps constant current. There's a little resistor here next to this D-pack IC, and it's setting the exact current. So again here, we can open it up, and we see that we have 3 LEDs suspended on copper wire. That's all it is, but it looks awesome. You want to make sure with your spacing that the LEDs are ideally hidden by the labels. Just makes it look a whole lot better. And here's an idea that I've been doing in Germany. It was actually published in the European magazine Elector, where instead of using plain water and colored LEDs, I was using UV active dye, like fluorescent sodium, for instance, which under UV light shines bright green. And then the LEDs I used were UV LEDs, that just looked so much more intense because the LED, in this case, you can see the LEDs glowing. Especially the one shining up, you can tell that it's the LED, that's the source of the light. But if it's a UV LED and the water is what's actually glowing, then it looks so much more majestic and so much more intense. So that's just an idea. If you want to play with this sort of stuff, try playing with UV active dyes, and you can get them very cheap on eBay and Amazon. Well, anyway, this was a super short project, and the only reason I even made a video about this is because some people asked me how I built those, and I just wanted to show that they're super easy, and pretty much anyone can build them. So I hope you liked it, and I'm also at the same time shooting a teardown video of something RF related, so if you're disappointed that this video isn't RF, well, sit tight, there'll be an RF video in just a moment. See you next time.